Hello, in this video I'll show you how I make an RC cylinder only with a mini lathe and optional a mill, without any CNC machine. Building is easier than you think. This video come out way too long and I believe too boring also, but I want to show here how to make RC cylinder from that to that, step by step, so everyone with a small Chinese lathe can make it. This is my third or fourth version of cylinder. I use one for a snowplow and after a year it won't leave a single drop of oil. On my YouTube channel you may already seen some of my hydraulic video. One of them is on third place by view numbers. It has nice amount of view and a good like ratio. But this video is made for a forum to show what I'm working on, make mostly from photos. So now I will make a new video how to make an RC cylinder step by step. Also in this old video I present the first version of cylinder with C-clip, which is not good because we got many oil leak there, and also show a little about making of valve. This time I will focus only on cylinder and show you some details and tricks how to make a nice small RC cylinder. Okay, start with the material we need to make a cylinder. 4mm steel round rod, 30mm aluminium round bar, 80mm brass round bar and 12 by 13 brass tube without stitch. Now check my sketches for easier work. This is the first version of cylinder which uses C-clip to assemble, but this is not good as I say already. Then I got sketches for smaller 11mm cylinder, and there is some sketches from adjustable pressure relief valve, which is not realized yet. And there is a second version of cylinder. But there is one problem. I use 70mm brass for front and rear end. That means that on top part we got only 2mm of material to cut M1.6 straight in it. I make one, but you must be extreme accurate there. So I start again from the beginning and come to this cylinder, as I call version 2.2. Also edit plans to look a bit better. Here you can see assembling cylinder and each individual parts with measures in millimeters. For plans I make random length of cylinder to explain how you calculate it. If I got cylinder tube length 100mm, we need shaft 120mm long. Total length of closed cylinder eye to eye is 131.5mm and the working area is 97mm. Working area is always 3mm less than a tube length, but everything is explained into plans. Here are some details of upper part, piston and lower part. Let's start to build now. First I'm going to make the cylinder tube for easier measure checking on other parts. This brass tube you can buy in RC model shop. It must be without a stitch inside and the measure 12 by 13mm, so wall is all 5mm thick. Cut a few millimeters longer than you need it. I just cut some random length. Then put into a lathe and finish one end. There is very important to cut inner edge by 45 degrees or more, as you can see there. If you don't cut this inner edge, you will damage the seal for the first time you push piston into tube. Then turn the tube around and trim it on lathe you want. I cut the inner edge also on other side, so later it doesn't matter how to turn the tube. End result must be something like this. Now I'll make this bottom part, which called base mount. When I drill with 10mm drill bit, the bottom will not be flat, but will stay the conus from the drill bit. But it's okay, this is just space for a piston nut. Cut a piece of 17mm brass bar and trim it on end. Then mark the center with the centering drill bit. With 10mm drill bit make 8mm deep hole. Now use the inner turning tool. If you got the digital readout on your lathe, just find the touch and set it to 0. Then increase the hole to 13mm, but only 3mm deep. The tube we make before must fit in that hole. Outer diameter is already 18mm, so I just sand it a bit for nice finish. Cut the edge with 45-degree turning tool. Cut it on total length about 21mm, so you can trim the other end and still got piece 20mm long. I turning 8mm from rear end for a few millimeter deep, but next time I turning this end to diameter about 9mm. This operation has no function, just base mount look better. I already said that there is no CNC machines for this project, so I must improvise a lot to make radius with manually fitting two axes at the same time. I make a radius gadget for this lathe, but improvising is faster than mounted. When we got rough turning the radius, finish it with the file and sandpaper, but be careful with the file around the rotation chuck. And that's the base mount we got out from lathe. Now mark 6 mm from bottom edge to make an oil pipe connection hole. Then drill with 2.5 mm drill bit and cut and treat into. Don't forget to sharp edge. On beginning I said that you can make cylinder only with a lathe and optional a mill. This is one of step I make on mill. Again, this process is just for better look. You can skip this step and the cylinder work anyway. Yes, I like slow motions. And I mill here to make base mount flat like real cylinder gut. It look much better if you do this. But if you don't own a mill, you can do it with hand saw or angel grinder and old school file. There's just one more step to do with this part. Drill a hole to mount a cylinder. I drill 5 mm, but you make hole dimension what your need is. We just finished the second part, which looks something like this. Let's make this upper part now. Put 18 mm brass rod into a lathe and face it. Then mark the center and drill with 12 mm drill bit more than 12 mm deep. Face again and cut the edge by 45 degrees. Then with inner turning tool increase the hole 3 mm deep to 13 mm, that the tube fit perfect. Just a bit more and here we go. Cut the piece a bit longer than 12 mm, then put in chuck from other side and trim it to 12 mm. Now increase the entire hole to 12.2 to 12.4 mm that you don't damage the seal and sharp edge when you push the piston into tube. And then increase 5 mm deep hole to 13 mm. And cut the edges just that much that they don't sharp. Here I got another homemade gadget to mount Proxon or Dremel tools into lathe. And here is the indicator fixed with magnet near chuck. On chuck flange I got marks divided on 4, 5 or 6 identical parts. This time I use spots that mark 60 degrees, so 6 spots in whole circle. With 1 mm drill bit, drill 4 to 5 mm deep, then turn for 60 degrees and repeat, until you got 6 hole around. Change the drill bit and increase the hole to 1.25 mm, which is the measure for cut M1.6 thread, but I will use 1.3 drill bit to easier cut that tiny thread. Now insert M1.6 thread cutter into Proxon chuck and cut the thread at least a few millimeters deep, just that you got quite a right angle from all sides. You'll continue cutting thread manually later. I bought this thread cutter on eBay 10 pieces for a few dollars and works just good in non-ferrous material. Take the piece out of lathe, prepare thread cutter and continue with cutting thread, until all the threads are about 4 to 5 mm deep, depend on what kind of screws you will use. Final part must look something like that. Now let's make this top cover part. First check if the Z-axis of lathe set in same position as when we drilled the top part. Then install 18 mm brass bar. And make 6 holes every 60 degrees with 1.5 mm drill bit, at least 2 mm deep. Change drill bit and increase the hole to 1.7 or 1.8 mm. Drill 4 mm hole through the center. Face it a bit to lose the sharp edge. Then cut it on about 2 mm long, but not till the end. Before you cut it, change the tools and cut the edges by 45 degrees, just that much that the edges won't be sharp. If we make a good job, all the holes must be aligned on part we make before. Now make this part out of aluminium which hold the seal on its place and lead the axis. I make this cylinder with some old plans, so the part come closer to tube and the oil pipe connection come right into this piece. That means that I must make additional hole on this part so the oil can go through. In your case just follow the plans and all will be okay. Put 13 mm or more aluminium round bar into a lathe and face it. Then mark center and drill with 4 mm drill bit at least 5 mm deep. Make outer diameter 30 mm so the part fit easily into top part. Then make a groove for seal on outer edge, dimension about 0.8 by 0.8 mm. Groove for rod seal I make with 6 mm drill bit. Just drill about 0.8 mm deep. Cut it a bit longer than 5 mm so you can trim it from other side to proper dimension. Don't forget to sharp edges. This is how the finished part must look, and the whole upper part of cylinder ready to assemble. If you can't fit the seal into that part, just put in lathe and increase the groove to about 0.9 mm. When you assemble it, the seal must look a bit out of surface like there, so you when tighten the top screws the seals squeeze a bit. And this is the mode I must to make for oil to get through. If you follow them plans, you don't need to make this. Now make the shaft. Put 4 mm steel rod into a lathe and trim it, then turning to 3 mm diameter 7 mm from the end. I got this tool for cutting treat into lathe, but the steel is so hard that I must to continue cutting it manually. Then cut it on length you need, trim it and cut M4 treat on this end. Cutting treat is really hard on that strong steel, so I cut it manually. Before the rod was finished, I put it into a lathe and sand it with fine sandpaper. Then polish it with a paper towel and polishing wax. Now make the piston. As I say, I work with some old plans, so I make a flat piston without that upper part. You just follow the plan and all go together like it must. Put 12 mm aluminium bar into a lathe and trim it. Mark center and drill. I just drilled 3 mm hole through. You need to drill 3 mm hole more than 7 mm deep, and then increase 4 mm deep to 4 mm diameter. 1 mm from end, make 1 mm wide groove about 0.8 mm deep for piston seal. Cut it to halfway, smooth edges and cut it away. This is how finished piston look like, but if you work by plans it will be a bit different. Now I got almost everything prepared to assembling, but before that we must do one more important step. Polishing the inner side of cylinder tube. Into boring head put polishing tool and add some polish wax on it, then just run the lathe and polish the tube. On outer side, take the fine sandpaper and clean the surface that the soldering will be stronger. Turn the tube around and repeat the process. Also, there is the last chance to smooth the inner edges, it's very important step. And now I got all parts needed ready to next step. I will solder together the upper part, tube and the bottom part. For soldering I will need a flux for better results, soldering wire and gas burner. But before that it's smart to clean a lathe, at least a bit. Then put bottom part into chuck and make sure that running in center. Mount in the tube and the back part which holds with live center on its place. Make sure again that everything running parallel, and be careful where you got the oil tube connectors. Then apply a bit of flux, turn on the gas burner and start heating and adding the soldering wire slowly. Don't add too much soldering wire, use just that much that the contacts solder around, otherwise it will break into the tube and you got additional problems. Repeat that on other side. Go to beer, coffee or something and let things to cool down. Then turning the edges by 45 degrees again to remove the excess solder. On both sides of course. Take the piece of fine sandpaper and brush the entire cylinder to a nice finish. Here you can see a bit of soldering wire which break into tube, so I must remove it with a small inner turning tool. Now look like we're ready to assembling the cylinder, but not yet guys, we still must make some tiny accessories. First I make this end rod mount, it's just a piece of aluminum with M4 treat. Insert a piece of 10 mm aluminum bar into chuck, face it and drill it with 5 mm drill bit or whatever your need is. Cut it on length 10 mm to half, then cut the edges and cut it away. Cut also inner edges. With 3.3 mm drill bit make hole through the center and cut M4 treat in it. And the rod mount is done. Now I will make this 90-degree hose mount. If you want to mount the hose like there on top of cylinder you don't need that part, but I make it for both sides. I'm sorry to forget recording one step there, but it's easy to make. Just take 6mm diameter brass bar and turn it 3mm from end to 3mm diameter. Then cut M3 thread on it and drill 1.5mm hole about 6 to 7mm deep. When you cut it on total length of 9mm, turn it around, face it and cut the edge by 45 degrees. If you got access to mill, flat a piece of surface. This step is only for better look. Also you can flat it with file or sandpaper. Then drill 2.5mm hole about 3mm deep and cut M3 thread, and that's it. Now I'll make this hose mount, which can be screwed into 90-degree mount or direct into cylinder. For that part I use 4mm hex brass rod. You can use round rod, but I think that the hex look better. After face the rod, turning the end to 3x3mm, cut M3 thread onto and drill 1.5mm hole at least 7mm deep. Leave 1mm of hex rod and turning the other to 2.5 diameter at least 3mm wide. Then I got a special knife to make this hose hook. It holds hose in its place more than you think. Many times I must cut the hose to get it off. For more scale look you can align surface around the hose connection. I think it looked better, but you need to be accurate. My precision was on vacation here. Easy way to do this is when you drill and cutting thread. You don't even take the piece out of vise to do that step and it will be in dead center. I think that I got everything prepared for assembling now. Before start assembling, carry part clean with compressed air, because single small chip can damage seal into cylinder. Then take the rod and put piston on it. Secure it with self-lock nut, which got a piece of plastic on end so the nut can't untighten by itself. Lube the piston with oil and add 10x1mm seal on it. Add some oil also into cylinder tube. Then slowly and carefully install the rod with piston into tube. If you don't go straight, try to move rod a bit left and right while pushing. But never try to put dry sealing into dry tube if you don't want to damage the seal. Before continue assembling, try to close bottom oil connector with finger, and then push rod into tube. If seal like it must, the rod must come out by itself. Apply a bit more oil into cylinder tube, then install the rod lid on its place. Add a bit of oil into sealing groove. Then install 11x1mm seal on its place. And 4x1 seal, but be careful with it that you don't damage it on the rod thread. Seals must be carefully installed on its place like you see here on that photo, otherwise it will be damaged when you tighten the top cover over them. When you think that all on its place, screw the cover with 3 screws. Tighten it evenly, then install other 3 screws and tighten them evenly one by one till the end. Then test the cylinder. Rod must go in and out without any resistance. Then try to close front or rear hose connection with finger and push the cylinder rod. It must return on previously position by itself. Look like the cylinder seal like it must. Make some tests with the compressed air. Then degrease the hose connection and assemble it. I use special thread lock for sealing the thread, but the basic thread lock will be okay for that. Use a bit of thread lock, screw it in 90-degree connector and tie it well. Add thread lock on 90-degree connector thread and screw it into a cylinder to position you want. Also you can use only hose connection, without 90-degree connector if it fit to your project. On cylinder rod mount M4 nut and round mount, then tighten the counter nut. That's it, cylinder is now ready to paint. I will make wet tests after painting to avoid oil over the surface. Now protect a part of rod with masking tape and add a piece of wire so you can hook somewhere when the color is drying. Also protect the hose connection on both sides. On towel apply some degreaser and degrease whole cylinder as much as you can. Just before painting I apply a bit of oil on the rod, so when I close the rod it makes protective film between the rod and seal. I apply a thin layer of putty spray on it first, but you can also apply a layer of primer or base color. Just make the layer thin, otherwise it won't look good, because you hide small details under the putty, and it will look like it's plastic. That's why some people don't even color the cylinder. When the first layer is dry, sand it a bit with fine sandpaper. Then apply color, orange yellow in my case, which look like real machines. Take time for that step and apply very thin layer, otherwise the color will leak down and that's look ugly. When the color is dry, remove the masking tape and the cylinder is ready to test, with hydraulic this time. But first check how it look. Here I got my single channel hydraulic pump and valve unit to power the snowplow on my Traxxas Summit. You may already seen in previous video. Just install hydraulic hose on new cylinder and it's ready to test. This is bigger cylinder than one before, so I need to add some oil into tank. When the cylinder is extended to full, there is maximum oil into the system. So in that position you need to get low level of oil into tank. Now connect the 2S lipo battery and see the full power. There's no oil leak and all look like work great, so make a power test. Here I improvised with pull weight gauge, but I got the result I want. On rod side I got 80 kg of pull power. Magam Haratsa, the producer of hydraulic pump, said that the pump give about 15 bar of pressure. Let's calculate a bit. I found some hydraulic calculator here, let's fill the form. Piston diameter is 12 mm, rod diameter is 4 mm, and the rod side force is 18 kg. That means that the pump gives almost 18 bar of pressure, and the bore side power of cylinder is more than 20 kg. I think that's more than great for that small cylinder. And also that's it for today. I hope you enjoyed this long boring video. If there be interest, I will make another video about how to make hydraulic valve only with a lathe. Like, share and subscribe if you like, and see you next time.